In this video, we're going to discuss techniques used to solve radical equations. At the beginning of this activity, we were given an equation that told us how long it would take for an object to fall a given distance. Right, the equation we used looked like this. So question 1 says, write an equation that must be solved to find how tall a building must be in order for an object to take 8.37 seconds to fall to the ground. All right, so we know the time, right? The time is the 8.37. What we don't know is the distance, right? How tall. All right, so that's the square root of d over 4. Right, so that's the equation we have to solve. We have to solve this equation for d. Right, there's several ways we can do it. We can use a numerical method. That means take out our calculator, and we'll press y equals. We'll erase whatever junk we have in here, and I am going to enter the square root of x, and make sure that if you have a newer calculator, you press the right arrow to get out from underneath the square root sign. If you have an older calculator, you'll probably have parentheses opened and closed. Okay, we want to divide that numerator by 4. Okay, so that's the right side of my equation. The left side of my equation would be the 8.37. And for problem 3, the intersection would actually give us the answer to problem 3. But for now, we want to do a table, right? It says using the numerical method. So I want to set up my table. Right? So I press second, I press window. Right? I want my table to start at 0. We're going to count by ones. Everything else should be on auto. Now above graph it says table, so I press second and graph. And we want to scroll down. How long does it take? Right? I want to see when does my y1 become 8. So you could see it's good. I'd have to scroll down quite a bit. So maybe I want to jump to a bigger number for x, right? Instead of having to keep pressing the down arrow, right? You see how my x is still too small, right? When I put in 31 feet, I get 1.39 seconds to hit the ground. So maybe I need a much bigger number. So if I go back to table set, instead of starting at 21, what if I start at 1,000? Okay, now I press second graph. All right, you see how I'm getting closer? Right, I'm at 7.9. I still need to get to 8. So what if I go back to second and window, and this time I'll try 1200. I press second, I press graph. Okay, now you see 1200 was too big, right? Because we want to get to 8.37. Okay, so I'm going to take one more stab. I'm going to press second and window, and I'm going to, instead of 1200, I'll use 1100. I press second and graph. And you see, okay, 1100, we're at 8.29. We need to get to 8.37. So it's close enough. If I press the down arrow, you'll see we're at 8.32, 8.33. We need to get to 8.37. So you're going to hear me, I'm repeatedly clicking the down arrow until this becomes 8.37. And there it is. Uh-oh, I hit the button too many times. Okay, so you can see it looks like somewhere between 1,120 feet and 1,121 feet, the time is 8.367 seconds, 8.37 seconds. So somewhere in between here, that's how high the object will be before it hits the ground. Okay, so if I drop something from a building that's 1,120 feet, it will take about 8.37 seconds to hit the ground. Okay, so in the numerical method, how do we actually express our answer? We're going to write 3 rows. So I'm going to write 1,120, 1,121, 1,122, and so on. So here's me expressing my answer using the table method. And I'm going to go with 1,121 feet. And again, that came from my table, right? 1,121 feet. So an object dropped from this height will take 8.37 seconds to hit the ground. Okay. Now, it says solve using a graphical method. Well, we've already graphed both sides of our equation. Right? Remember, the original equation was this, right? So I graphed the left side, the right side, the intersection. So now we need a proper window. So right away, we know that our D is the x-axis, and it's going to go to at least 1,121. So I think we want to press the window key. I'm going to start at 0, and my x max has to be at least as big as 1,121. So I'm going to enter, I don't know, 1,400. And maybe I'll count by 140 to get 10 tick marks. My time will go from 0 to 10 seconds is good enough. Remember, we need a number that's bigger than 8.37, so 10 should work. And I press graph. Okay, there's my radical function, and we're looking for the intersection. And now I press second, trace, number 5 for intersection, enter, 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 and we get 1,120. And if we round this, right, that would give us the 1,121 feet, right, at 8.3 seconds. So we've now solved this by using a graphical method. And on a test or a quiz, I want you to actually sketch the graph as your solution if you're going to graph it. Now it will look something like this. And again, this is no Picasso, but I did try to sketch this graph as best I could using a touch screen. But the most important thing is, label your axis, right? Time, distance, and the intersection point is 1,121 feet, 8.37. Sometimes I might ask you to write a complete sentence to describe your results. So you would say, an object dropped from a height of 1,121 feet will take 8.37 seconds to hit the ground. Okay. All right, so it says the equation that we just solved is a radical equation because there's a variable under the radical sign, right? So here's the radical sign. There's a variable under it, so it's called a radical equation. And these are a few examples. Okay, so let's stop here, and in the next video, we'll continue with a few of these examples.